The paper we're diving into today is called Dissolution of Calories, An Introduction to Modern Nutrition by AustonCherbonneaux. Quite a provocative title, right?
Oh, absolutely. As soon as I saw dissolution of calories, I knew this wasn't your typical nutrition discussion. Sherbonneaux really wants to challenge how we've been taught to think about food energy.
Right, and that's really the core question of the paper. Are calories, as a scientific and practical model, actually the best, or even an accurate, way to understand how our bodies use energy from food? And what if we've been basically misunderstanding this for over a century?
Yeah, and the implications are kind of huge because, calories are basically baked into how we talk about dieting, weight loss, exercise science, even like the labels on your potato chips. The whole calories in, calories out thing, CICO, is this bedrock idea. So Sherbonneaux is questioning that bedrock. Is that solid ground or quicksand?
Exactly. And he grounds the conversation in the history. Lavoisier, Rubner, Atwater, even Dr. Lulu Hunt Peters, and then walks us right up to modern molecular physics. There's this fascinating, almost detective story element as he peels back where the whole calorie as a unit of biological energy comes from.
So should we try to summarize the gist? Sherbonneaux's main argument is basically our bodies aren't little combustion engines. Calories measure heat from burning food in a lab. But our cells? They run on electrochemical reactions based on how electrons move within molecules.
Right. There's no tiny fire in our mitochondria. I love the way he describes that. Instead, energy in living systems is more about, the arrangement and movement of electrons and protons inside our nutrient molecules, not burning carbon with oxygen.
He takes us through how food is broken down to acetyl groups, which then feed into the Krebs cycle and electron transport chain in the mitochondria. And that's all about moving electrons and protons, creating gradients, and boom, fueling everything from muscle contractions to keeping your body warm.
And here's where it gets, I think, both radical and almost surprisingly practical. Sherbonneaux is saying that calories, measuring the heat potentially in food, misses the bigger picture. All nutrients, whether they're caloric or not, can play energetic roles in biology. Kinda mind-bending, honestly.
Yeah, so when people talk about non-caloric nutrients like water or vitamins, he's like, well, they still participate in energy exchanges, just not in the way a calorimeter can measure. It's not like water sits there uselessly. We need it for chemical gradients and reactions, which are, essential for life.
I think the other big takeaway is how the model for nutrition should maybe shift. He proposes moving away from the CICO model and instead using a grams model, measuring actual nutrient types, tracking how the body takes them in, uses them, disposes of them. So, intake, call, use, disposal. Like a more systems-based approach.
And he even has that more practical intake, call, use version, which is almost, well, honestly, it sounds like advice you'd give your friend at the gym. Track what you eat, give your body a reason to use it, like exercise, and look at what changes.
It's funny, it kind of demystifies things that the calorie model made confusing. For instance, the paper points out that calories never actually explained individual variations well, like why two people on the same calories might get wildly different results. It's all in the specifics of metabolism, hormones, how nutrients move through your body, and just so much more.
Yeah, and also, wait, can we talk about how the paper mentions the Minnesota starvation experiment? That's wild. Like World War II volunteers purposefully starved to study recovery, and the calorie became the anchor for how they understood, getting back to normal. The historical lens is kind of humbling, actually.
It really is. And Sherbonneaux's point is that science advances. What was obviously true in the 1890s looks, frankly, kind of quaint now. We know so much more about physics, biology, even chemistry. And yet, the calorie as a central unit keeps hanging on.
Okay, minor digression. I once tried to calculate how many calories I burned watching Netflix, just lying there. It was not impressive. But apparently, even that burn isn't literal burning, right? It's mitochondria doing their electron shuffle.
Exactly.